I am Anil Kumar. Welcome to my series on polynomial graph. In this video, we will discuss cubic functions. We'll begin with concepts to sketch graph of cubic functions. Now these graphs can be sketched once we find the zeros and the end behavior. That helps us to sketch the cubic function. We'll take up actually 6 examples as shown here to sketch the functions, and then we'll also find the equation from the graph. So that will be 3 more. So I hope that will give you good practice to understand the concepts. Now these concepts will be applied to quartic and higher degree polynomials, and that makes this video more important. So let's begin with the very basic concepts. For sketching a cubic function in particular, it is important to understand that a cubic function could be written in the form of, let us say, f of x equals to ax cubed plus bx squared plus cx plus d. Two important things here. One is the degree. Of course, the degree is the highest power, which is 3. The other one is the leading coefficient. Now, leading coefficient will be a. Now, the value of a could be either greater than 0 or it could be less than 0. As you know, a cannot be equal to 0 for the function to be cubic, right? Now, depending on the scenario, whether a is greater or less than 0, we can decide the end behavior. So end behavior will be kind of like this. Let me write down here end behavior. For both cases. If a is greater than 0, that means right side up. So the graph is going to be up. And on this side, it is down. Since we know it's an odd degree, it will be in opposite ends. But if a is less than 0, leading coefficient is negative, in that case, the right side will be down and the left side will be up. So that is the end behavior. You could actually write the end behavior in the form that when x approaches negative infinity, y approaches negative infinity, and when x approaches positive infinity, y approaches positive infinity. That is the case when we are talking about leading coefficient being positive, right? This is for positive a. If the value is negative leading coefficient, in that case the end behavior will be when x approaches negative infinity, as you can see here, y approaches positive infinity. When x approaches positive infinity, then y approaches negative infinity. So from our equation, we need to figure out what is the end behavior to get from where the graph will start and from where it is going to end. It is definitely going to go diagonally across, right? So the graph is always diagonally across. Perfect. So that is important to understand. The other thing is about zeros. So we'll consider the zeros and multiplicity with the help of examples, which have order, or sometimes we refer to this as multiplicity of zeros. So while sketching, we'll look into how the zeros affect the behavior of the curve at the x-intercept. So let's take up an example now. Example number 1 for us is find zeros and end behavior to sketch the graph of a cubic function. So let's begin with writing the zeros and the end behavior of the function. Function given to us is f of x equals to x plus 1 times x minus 2 times x minus 3. Zeros will make these factors 0, correct? So we can write these zeros first. Zeros are at x equals to, the first one is at minus 1, this is at 2, and this one is at 3. Now let's write down the order of 0 or the multiplicity. This is linear, right? So all are linear, so I'm writing in brackets 1. So that means all are linear zeros. End behavior. Let's find the leading coefficient A. What is the leading coefficient in this case? Should you open the bracket to figure it out? I don't think so. What you have to do is basically multiply the x terms to get the leading coefficient. Let me show you how. Leading coefficient will be product of these x terms. Is that clear to you? Right? So that is a value which you're going to get. So in this particular case, the value of a is going to be x times x times x, which is x cubed. So the leading coefficient of a is 1. So basically, we should write this as a equals to 1. The term here will be, that is the leading term. So the value of a is equal to 1 in this particular case. Do you see that? So that becomes the leading coefficient, and clearly the value of a is greater than 0. Now with that in mind, let's try to sketch the graph. So let me draw the axis first. So we have the horizontal x-axis and the vertical y-axis. Let's mark the zeros to begin with. Zeros are at minus 1, 2, and 3. Let's say this is minus 1 for us, this is 2, and this is 3. I'm going to make very approximate graphs. Another important point here to also find before sketching is the y-intercept. So let's also find the y-intercept in the given case. So what is the y-intercept? The y-intercept is the value when x is equal to 0. So when you substitute 0 in this case, you get 1 times minus 2 times minus 3. When you multiply these, minus and minus gives you plus. So you get plus 6. So it is positive, right? So we got the y-intercept value, which is 6. Now, let's begin with the end behavior. We figure out that a is positive. That means right side is up. So this side will be up and the left side will be down. The cubic functions are on the opposite ends, beginning and end. Now, since all these zeros are linear, if you start from quadrant 3, you have to cross in this fashion, like a straight line. So I'm drawing these straight lines only to indicate that the nature of the curve is straight line at the x-intercept, and that is being defined by the zeros. Connecting these points will actually give us the graph of the function. So let me just connect them and sketch the graph. Smooth curve going through these points will actually give us the graph. So we already have the x-intercepts. Let me write down the values which are at minus 1, 2, and 3. The y-intercept value was calculated as 6. So that becomes the graph of the given function. Is that absolutely clear? That is how we are going to draw it. Now let's take the next example, and I'm sure by the end of this video you will be an expert. Now here we have g of x equals to x squared times x plus 4. Let's begin with finding the y-intercept first, which is placing 0 for x. So it will be 0 times 0 plus 4. It means that is 0. That means that the graph goes through the origin, right? The y-intercept is the origin itself. Now, let us find the x-intercepts. X-intercepts will be when each factor is 0. So x squared equals to 0. That is 1. And the second one is x plus 4 equals to 0. So the first one gives you x equals to 0, the other one gives you x equals to minus 4. We have two x-intercepts. These are also called the zeros. Now, let's figure out the order of zeros. At x equals to 1, it is x squared. Do you see this part? X squared. And therefore, the order in this particular case is 2. So, at x equals to 0, we have order 2. We also say double 0. Or the multiplicity is 2, right? But at the x equals to minus 4, the order is 1. I'm writing in brackets since I want to show it in the graph in brackets. Okay, so we have the x and y intercepts. How about the leading coefficient a? Let me write an for leading coefficient. So when you multiply these terms, which are x squared and x, what do you get? You get x cubed, and therefore the leading coefficient should be 1. You get an idea. You do not have to really open up the bracket. Just multiply the x terms. Now, let's try to sketch this graph. We have zeros at minus 4 and 1. And 0, minus 4 and 0, right? So one 0 is at 0. The other one is at minus 4. The end behavior is, since an is positive, an is greater than 1, right side up, and the left side is down. That is the end behavior, right? So this means when x approaches negative infinity, y approaches negative infinity. When x approaches positive infinity, y approaches positive infinity, as shown by these arrows. Now let's look into the zeros once again. The 0 at minus 4 is linear, right? This is a linear term. So it'll go straight here. However, the 0 at 0 is because of x squared. So it is going to turn like a parabola. You get the idea. So what I'm trying to say here is that this particular 0 has order of 2. Or you can say it's a double 0. Correct? So at this point, what happens? Curve turns like a parabola. That is the importance of the zeros, or the order of the roots at this particular point. Now, we are in a good position to sketch the graph. So let's do it. We'll start from quadrant 3, go like a straight line, a smooth curve, turning, and then going up. So that becomes the graph of the given function. Is that clear to you? Perfect. So that is how we are going to sketch it. Let's move on and take the third question. In this particular case, what do you notice? I would like you to pause the video and answer the question. Well, we notice that minus 2x times x squared, right? So what is the leading term? Leading term in this case will be when you multiply these x's, right? So in this case, the leading term is minus 2x cubed. So definitely the leading coefficient an is minus 2. So we see that a is less than 0. And that means that when x is approaching negative infinity, y will be approaching positive infinity. And when x approaches positive infinity, y is approaching negative infinity. On a graph, you could easily show it by arrows, as we had been doing. So since leading coefficient is negative, right side will be down and the left side will be up. That is what we're trying to say in writing x is approaching minus infinity means y is approaching positive infinity. Does it make sense to you? Perfect. Okay, now let's look into zeros and their multiplicity. So let's write down zeros. zeros is a better term than the x-intercepts, since zeros also define the behavior of the curve. So one zero is for minus 2x equals to 0. The other one is because of x squared minus 9. Correct? So that gives you 1 0, which is at x equals to 0. This is of multiplicity 1. However, x squared minus 9, that means we have two zeros with one factor. 0 here is at x equals to plus and minus 3. Both are of 1 degree. They're two different zeros, plus and minus 3. Correct? Let's also find the y-intercept. So in this particular case, what is the y-intercept? Y-intercept will be, by placing 0, what do we get? We get 0 times whatever, which will be 0. So the y-intercept is also at the origin itself. Now let's mark our zeros and sketch the graph. So we have two zeros. One is at minus 3, the other one is at plus 3, and the third one, we have three zeros of course, and the third one is at origin itself. Now all are linear zeros, right? So 1 in the brackets indicates that they are all linear zeros. Correct? Let us now sketch this particular graph. We are starting from quadrant 2 and we are going to end in quadrant 4. And all these zeros are linear, so the graph will go like a straight line as shown here. Let's connect these points and sketch the graph. Let me use a different color. Okay, so the graph could be kind of like this. Do you see that? So that will be the cubic function which can represent the given equation. Is that clear to you? Perfect. Let's move on and take the next example. Question number 4. F of x is given to us as x equals to 1 minus 2x times 3 plus x. Let us rewrite this particular equation. F of x is equal to x times 1 minus 2x times 3 plus x. Now you should always write x terms first and factor out the negative. So what we have here is minus 2x. So what we are going to do here is that we'll factor this and rewrite. Now this is a very, very critical step. So minus 2 I'm going to write outside. And when I factor, it becomes x minus half. Does it make sense to you? And rest of the terms I'm writing as such. So 3 plus x also, the good way is to write x plus 3. That will help you to avoid a lot of mistakes. So this is a very critical step. I hope you have understood what we have done. We factored minus 2 and wrote that term, the second term in this case, with minus 2 times x minus half, right? And the other terms are as such. Once you do that, then you write down all your x-intercepts. So in this case, we are calling these x-intercepts at zeros, right? Zeros and x-intercepts, what is the difference? Well, we learned that zeros also define the behavior of the curve. Okay, so that gives you 1 0 at x equals to half. And in this case, at x equals to 0, and here at x equals to minus 3. The order being 1 in all the three cases. These are all linear zeros. Let's also find the y-intercept. That is the value of the function when x equals to 0. So f of 0 is what? As soon as I substitute 0 here, we get 0. Leading coefficient. an, the leading coefficient is what? When you multiply these x terms, you get minus 2. So minus 2 is your leading coefficient. What did we do? We multiplied minus 2, this x, the other x, and the third x. That gave us minus 2x cubed. So that is the leading term. Leading coefficient is the coefficient of x cubed, which is minus 2. Is that clear to you? So now we get an, the leading coefficient, which is less than 0. That means what? That means that when x approaches negative infinity, what happens to y? Y approaches positive. It reverses. And when x approaches positive infinity, y approaches negative infinity. Right? So we'll take this into consideration while sketching our graph. We have three zeros, one at minus 3, the other one at origin, and then at plus half. Let's begin by marking our end behavior, which is this time from quadrant 2 to 4, right? Since the leading coefficient is negative. Zeros are at half, 0, and minus 3. So let's mark minus 3 first, and then 0, and then half. All are linear zeros. Beginning from quadrant 2, we are coming down like a straight line, going up like a straight line, and then coming down. Connecting these graphs will give us the graph of the function. Do you see that? So that is how you're going to sketch the cubic function from the given equation. Is that clear? Now when we say sketch, then you don't really have to find the maximum and minimum values, okay? We'll leave that part for calculus, right? The advanced functions. Now, let's look into the next example, which is question number 5 for us. This time, the equation given to us is f of x equals to 6x squared minus 3x cubed. Now, this is not factored, so we should factor this first. So we should take minus 3 first, right? That is a negative term, leading coefficient, which is common. X squared is also common for us. So once you do that, you get x minus 2 as your other factor. So you have two factors here, and clearly the zeros are at x equals to 0 and at x equals to plus 2. And what is the order of these zeros? Well, the order of zeros are 2 and 1. The first zero here is of order 2. Do you see that? X squared. So x squared gives you two roots at that particular point, right? So it is a double root at that particular point. Clear? And now let's look into the end behavior. An is clearly minus 3. So an is less than 0. So that really tells you that on a graph which will be going from, since the leading coefficient is negative, going from quadrant 2 to quadrant 4. Perfect. This is because of the leading coefficient. So let's write down the end behavior, which is x when approaching negative infinity. In that case, y approaches positive infinity. When x approaches positive infinity, y will approach negative infinity. Perfect. Y-intercept is the next point, and since if I substitute 0 for x, I get 0. That means origin is the y-intercept. Okay, so now we got x-intercept at 0 and x-intercept at 2. So these are the 2 points. We also know that the graph is moving from quadrant 2 to quadrant 4. Order of these zeros is what? Let me write down the order also. At 0, the order is 2. And at 2, the order is 1. So at 0, the graph is going to turn like this. And at 1, it will go like a straight line. That is what we mean. So let me again use this ink and then sketch the graph with a smooth curve. And that is how the graph is going to look like. Is that clear to you? Perfect. So we are already halfway through, and I hope by now you have got good concept of sketching cubic functions. I'd like you to now pause the video, copy this particular equation, and sketch the graph. You need to factor to find the zeros first. So let's begin. y equals to x times x squared minus 3x plus 2. So that is product and sum. We could write this as x times 2 times 1, both negative, right? So we get 3 factors, all are linear. So in this case, the zeros are at x equals to 0, x equals to 2, and x equals to 1. The order of these zeros is all 1. So when it is 1, we normally do not write 1. So it is taken as a default value. And as far as the y-intercept is concerned, the value of the function at 0 is 0. The leading coefficient is clearly multiplying these two terms, x and x squared. And therefore, we get a leading coefficient an as 1, and we see that an is positive. So that gives you the end behavior, correct? You can mark the end behavior on the graph saying it is going to be right side up and left side will be down, right? Now mark the zeros. The zeros are at 0, 2 and 1. So let's say this is 1 and that is 2 for us. So those are the zeros. So at 0, at 1 and at 2. All are linear zeros and therefore we'll just connect with a smooth graph which will cross them like a straight line. So we'll make a graph like this. Is it clear to you? So that is how we are going to sketch the cubic function for the given equation. Isn't that simple? Perfect. Now let's take up the next question, which is find the equation from the graph. Now this time the graph is given to us and let us find the equation. Well, here we have a cubic equation. So this looks like the function which is cubic in nature. So it's a cubic function. However, normally the cubic function is like this. Let me just explain you how do we get the equation from the given graph. So if I sketch x cube, it is going to be like this. So this is the graph of x cube, which will go through 0. Perfect. So that is the saddle point. Now in this case, the saddle point has moved and has shifted right by how many units? This is 2 written here. So it has shifted 1 unit to the right and it has gone down by 2 units. So that is your translation. Do you get the idea? So the translation could be written as 1 unit right and 2 units down. So that tells you that the function f of x, which is definitely a cubic function from the graph itself, could be written as 1 unit right means x minus 1 whole cube and 2 units down means minus 2. So that becomes the answer for the given question. Is that clear to you? So that is how, using transformations, we could get the equation from the given graph. Perfect. Let's take another example. Now this time, the graph we are given the roots. Whenever the roots are given to you, you can use the concepts learned. So what we notice here is that we have a root here. So let's write down the roots. So we have zeros. Let's write down the zeros. We are doing the reverse calculation. One of the 0 is at x equals to minus 4 and the other 0 is at origin. Let's write down the order of these zeros. Since it is a turning point, the order is 2 and that is like a linear function, the order is 1. And therefore, we can write this function f of x as equal to a times, that is a family of curve. First 0 is at, let's say, minus 4, so it will be x plus 4 the factor. Then we have a 0 at 0, x. Now the first 0 at minus 4 has multiplicity or order of 2, so this term will be squared. You get the idea. So we have connected this 2 with the square. Perfect. Now the question is, how do we find the value of a? To find the value of a, we should look for a point on the graph which can be accurately read. So on this particular graph, we say that this particular point is a good point to consider, where for value of 1, the y value is minus 5. Normally, that will be given to you. So we'll use this point, let's call this point as P, which is 1 minus 5, to calculate the value of A. It really means that for x equals to 1, f of x is minus 5. So I'll write minus 5 here for f of x, A, and for 1 for x. And we'll calculate the value of A. So we get minus 5 equals to A times 5 square, or we can say minus 5 by 25, which is 5 square, is the value of A, and that is minus 1 over 5. So that is how we get the value of A. Now we can write down the function f of x is equal to minus 1 over 5 x times x plus 4 whole square. Is that clear to you? Now that is a very important question. So in this question, you saw how a point on the curve actually gives you a specific function. Writing initially with a gives you a general equation. Now, point defines the curve uniquely, right? So apart from the x-intercepts I'm talking about, right? So that particular point is very important. Normally, we had been using the y-intercept, but in case the y-intercept is a 0, we have to take an additional point. So let's write down a note here. Take additional point. Okay. If y-intercept is 0. Okay, let me just push it in here. Perfect. Does it make sense to you? So in this case, the y-intercept was at the origin, and therefore we had to take an additional point to really define our function. So that helped, right? Let's take the last example now. The example here is another cubic function, and we need to write the equation of this particular cubic function. I would like you to pause the video, answer this particular question, and then look into my suggestion. Now, how should we begin? We should begin by finding the x-intercepts. We know we have all linear zeros, right? So we have linear zeros. At which point? At x equals 2, the point here is minus 3, then we have 0, and at 2. So at these 3 points. And that gives you the function f of x as equal to a times, a gives you the specific function once we define a point, x plus 3, that is a factor because of 0 at minus 3, x and at x minus 2. Now to find the value of a, again, this time we have the 0 at the origin. Y-intercept is also 0, so we have to define another point, figure out from the graph which could be a good point, and then we have to find the value of a. So select a point. Normally it should be given to you, right? So we will assume a point here. Since this graph is not so clear to me, so I will take a point here, which is for me at 1, I'm taking this point as minus 4. So that is the point I'm going to consider. Let's call this point as P. So if I substitute 1 here, I should get minus 4. Right? So A times 1 plus 3 times 1 times 1 minus 2. So we get minus 4 equals to a times 4 times 1, and this is minus 1. So we get minus 4 equals to minus 4a, and that gives you the value of a as equal to 1. So that is the result. And since a is 1, we'll write the function as f of x equals to x plus 3 times x minus 2. It is always better to write x as such in the very beginning. So let's rewrite this equation as x times x plus 3 times x minus 2. Is that clear to you? So that is how we get the equation of the function from the given graph. So you have learned the importance of identifying another point on the graph to specifically write equation of the given graph, right? So you begin with a general equation and end up with the exact equation for the graph that is expected. That brings us to the end of this particular video. And here what we have learned is general concepts of sketching the graph of cubic function. These concepts can be applied to all polynomials. We have in general had a couple of steps. First is to find the zeros and also the order. So when I say zeros, let me write down. Zeros means we have to include multiplicity or order. So they define behavior of curve. So they are not simple x-intercepts. Apart from x-intercepts, they also tell you the type of turning point. It could be like a saddle point or could be a straight line, as depending on the order of the zero, right? So we took up different examples in this particular case, and end behavior was defined with leading coefficient, correct? So leading coefficient and the zeros helped us to sketch the graph. To find the equation from the graph, we identified a point. So let me write down a note here. Identify a point on the graph to write this specific equation, right? So those are critical things which we have learned. I hope that helps. After this, you can watch my videos on quartic functions and sketching general polynomials. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.